In Chapter 3, you learned about how the combination of the pressure gradient force, the Coriolis effect, and friction combine to create high and low pressure systems. A low pressure system in the northern hemisphere is characterized by wind blowing towards the center, rotating counterclockwise, and rising and cooling air. They are associated with clouds and rain and include thunderstorms, tornadoes, hurricanes, and mid-latitude cyclones. High-pressure systems begin with air from the upper atmosphere, descending down towards the surface, rotating clockwise, and then diverging from the center at the surface. They are associated with dry conditions. On a non-rotating Earth, with no continents, the unequal heating of the equator and the poles would create 3 pressure belts, an equatorial low and 2 polar highs. These would be connected by winds that blow from the high pressure at the poles to the low pressure at the equator. But a model of atmospheric circulation becomes more complicated when rotation is added. There are 7 pressure belts and 6 wind systems. On this animation, you can see that the system begins with rising air at the equator. This is a low pressure system here. This rising air rises and spreads out towards the poles, but descends around 30 degrees latitude, creating high pressure systems there. The air returns to the equator as the trade winds. But some of the air will travel towards the poles as the westerly winds. We will return to the westerlies in just a moment, but first we will jump to the poles to see what's going on there. The cold air at the poles is heavy and dense and forms high-pressure systems and winds blowing away from the poles and towards the equator as the easterly winds. The easterly winds blow directly into the westerly winds, and the convergence of these 2 winds causes rapid uplift and massive storms called mid-latitude cyclones. These are the storms that we in California get in the winter, and you probably just hear them referred to as storms. Not such a fancy name for the biggest storms on Earth. The model becomes even more complex when we add continents and seasonal variation. The pressure belts are interrupted by the continents and move latitudinally as the seasons change. The global atmospheric circulation is the primary mechanism for transferring the surplus of energy from the equator to the poles. We will learn more about this complex system next week in Chapter 7.